Hi all, this is second video to our roadmap to the CCNA for learning the CCNA topics, and today will be our first lab, that is the topic of router on a stick. Let's explain what is a router on a stick first, and let's learn what is a router on a stick. Router on a stick topic doesn't mean that a network configuration that enables a single physical interface to route traffic between multiple VLANs. A network configuration that enables a single physical interface to route traffic between the multiple VLANs. When you have different devices connected to a switch and you made it to different section of areas, specifically you want you connected two PCs, and one PC you put in one room and you put in a second PC in another room. You want to route traffic separately for the uh, one PC and separately for the second PC. Then you need to route the traffic separately, so that in a previously what we do is connect two different wires to the router interface, and then we route the traffic to the different VLANs. But that takes a lot of wiring and a lot of mesh right there. So what we have got from the IEEE standard is 802.1q standard, and we will see it further, where we're going to configure uh, the VLAN at a trunk port and IP addressing in a router. And for now, let's go ahead and configure the router and a stick lab. It will take time for me to work in the Cisco Packet Tracer, so let me, yeah, it's open right now. So I have already created a topology a diagram to understand easily how our network diagram works. So let me open the file that I have created a topology already. Here we see router and a stick, and here you go, we have the topology right here. Let's understand the topology first before we starting to configure the real devices. And the devices I have taken: one router, one switch, and two PCs, two different VLANs. Their VLAN I have configured two different VLANs with the name of VLAN 10 with the name of HR, and VLAN 20 with the name of sales. These are in two different areas in an organization or any of office area. So let's see the connection and device configuration. Here first I will tell you what model of the devices I have taken. The router I have taken 2911 model, and the switch I have taken 2960 Cisco. These are all Cisco models. We don't have any other models. For the PC doesn't have any model, just a PC is a PC. And the interfaces I have connected from the router to switch 0/0 G gigabit Ethernet 0/0, and to the switch I have connected with G0/1, and from the switch to PC I have connected with F fast Ethernet 0/1, and PC at PC fast Ethernet 0. We don't have any other interface at PC. So from for the second interface to the PC2, I have connected with fast Ethernet 0/2, and at the PC it will be the default fast Ethernet 0 interface. So let's see what are the IP addresses we have given for the different VLANs. For the first VLAN, for the interface F0/1, that is on a HR, that's named by the HR with a PC1 device, and we have given the IP address 192.168.10.0 0/24. Why we have used 24? Because we need to have a 22,000, oh, sorry, 255 host. The last of each octet having a 255 host, and one is a broadcast ID, and here we see 10.0 for the VLAN 10 and 20.0 for the VLAN 20. And let's take first the devices. Here we see 2911. We don't have any name or text right here. Why? Because yesterday we have told in a preferences tab we can put a tab labels of device name and model. Here we see you can get a model and router, because it will clearly strip out all of our configuration. So I'm not choosing to put all these labels here. So I want to choose a text box, better preference. I will choose a text box here and add 2911 for the better understanding. uh, and then let's take a switch. I'm taking switch. I added switch right here. Another text box 2960, and then let's go for the PCs. You will find the PCs in end devices, and PC1 and PC2. Let's add a text box here, PC1, here PC2, here switch one in I'm taking short format, and a router 1 R1 I'm configured as R1, not a router 1 in a fully form, because it takes a lot of space. Let's choose your connections. I told you yesterday, when we have a different devices, we can connect to with we have to connect with the copper straight through cable. You can also connect with the copper crossover cable, because the modern devices having uh, standard auto MDIX that automatically detects the connection type and changes the data route path. So I am connecting the router to switch with a gigabit Ethernet, the same connections I have given here. You can check, and let me also put the notations right here. With you can also do drawings, on-screen drawings in a Cisco Packet Tracer. It's an easy one. And here you see I draw the eclipse, and for this one also one eclipse, whatever it is. And let's go add a text box inside. It's VLAN 10 name HR, and VLAN 20 with the name sales, and let's add a IP address box here outside 192.168.10.0/24, 192.168.20.0/24. You can ask me why we are using a 24, we cannot use a less than that. We can use it, but it will comes under the CID annotation. The devices will be lesser, and we cannot use lesser IP address as less subnet, because this is a class 3 IP address. You have to range from the 24 to 32, but you can also choose from the 18 or 17 or 16 also, and it will comes under the CID annotation, and you have to choose from the third octet, not the fourth octet. So right now we have a 255 devices, and 255 devices we can assign in the both VLANs. but we only have a two device right now, so it's all right. We can it because these IP addresses are the local, so no wastage in IP address. Let's go through configuration. First we go configure the configure the switch, and yesterday we have seen the physical overview of the switch. So let's directly go to configuration, and it's a user uh, execution mode, and type enable. Let's see any VLAN. No, we didn't have any VLAN here. Let's what's our goal is to add these two VLANs to our creation of VLAN creation. First we have to create the VLANs. Let's create. For entering the global configuration we have to type the conft, and let's create a VLAN. First VLAN 10. I have created VLAN 10, name it as a HR, and second VLAN 20, and name it as sales, and exit. And let's check. In a global configuration, if you want to do any troubleshooting commands, you have to force it with a do command. Let's do it, do vsh VLANs, and check any VLAN created. Yes, we can see two VLANs created. So let's assign PC1 and PC2 to VLAN 1 and VLAN 2. Yesterday we have talked about switch port mode. Let's right now get interface F0/1, and right now let's access a switch port, put it in a mode access mode, and let's access a switch port with the VLAN 10. Switch port access VLAN 10, and right now it has access to VLAN. Let's access the interface F0/2, interface F0/2, and switch port, put in more access. And let's access with the VLAN 20. Switch port access VLAN 20, and let's check again VSH VLAN. Here we see for the VLAN 10 we have assigned first Ethernet 0/1, and for VLAN 20 the sales we have assigned the F0/2. Right now we have to assign the trunk port. Let's discuss what is a trunk port. Trunk port we configure uh, to carry the traffic for the multiple VLANs over a single physical link. To identify the VLAN, Ethernet frame belongs to the switch uses 802.1q tagging, and without trunk port you need one cable for each VLAN. We have discussed like here you have two VLANs, so right now you having only one single cable right here. That's because we having a standard 802.1q IEEE standard, so that can carry traffic for the multiple VLANs when we configure the encapsulation dot one q. But without IEEE standard 802.1q, we have to connect the two cable, three cable. How many VLANs we have? Each VLAN have to connect with a separate cables. So right now we don't need to have separate cables. So that's what our trunk port means. So trunk, if we configure the trunk port, that can carry the traffic for the multiple VLANs. Let's configure the trunk port for the G0/1. Why we configure for trunk port for the G0/1? Because the traffic is coming from the router to switch. So whatever the interface we have connected to switch from the router, that we need to take as a trunk port. Let's take G0/1, and let's do this command switch port mode trunk, right, Right now our interface from the connection from the interface to switch for the interface gigabit ethernet 0/1 is right now on a trunk port mode. So let's see again, do sh in brief. Sorry, it doesn't work in here. So do sh VLAN. Here the VLANs are created already. So let's go to router and configure the IP address, and if the dialog we say no, enter, enable from the user execution mode, and a privilege. Let's check IP in brief. We have a 3 gigabit ethernet 0/1 0/0 0/1 0/2. These three interfaces are down right now. We have to up whatever the interface we have connected. Let's check what are the interface we have connected. PC switch the only 0/1 and 0/0, but at the initial gateway we have 0/0, so we only have to configure the 0/0. Sorry. First we need to put the connection in up mode, so take int 0/0. No, how do you put no shutdown? And let's check if it's off or not. Yes, we see the green light here glowing up. It says the line protocol interface is changing state to off, and here we go. And let's configure the sub interfaces G0/0.10. Yesterday we have seen it, and it has changed to 0/0. And let's use the command encapsulation dot 1q and VLAN 10. Why we use the encapsulation dot 1q? Because this is the standard IEEE standard that says to the route Ethernet frame, let's transfer this frame to VLAN 10, and this Ethernet frame to VLAN 20, this Ethernet to 10, 20, 30, whatever the uh, uh, VLAN you have created and given here, VLAN ID you have given here, that Ethernet frame will be transferred to the specific VLAN. And let's see what the Ethernet frame looks like. And here we have a original Ethernet frame. There we have a different Ethernet frame. One is a original Ethernet frame, and another one is a tagged Ethernet frame. What original Ethernet frame having is actually that have, let's see in a notepad. The second point, if you want, you can take a note of it. First we have a preamble. After preamble we have a start frame delimiter, and after that destination address and a source address, and then Ethernet type or length, and then payload, and then at the end we will have a FCS frame checker sequence. I will explain what are all these. It's an original Ethernet frame. Preamble is a starting data bit of the Ethernet frame, and start frame delimiter is it states the end of the preamble and the start of the destination address. And destination address is a destination MAC address, and the source address is the source MAC address, and Ethernet type, what type of the Ethernet, and length of the Ethernet type, and payload. Payload is the actual data from the upper layers, like application layer, session layer, and presentation layer. And FCS is a frame check sequence that is used for checking the errors. And preamble, it's 7 bytes. Preamble is a 7 bits, and start frame delimiter is a 1 bit, and destination address is 16 bits, and source address is 16 bits, and Ethernet type or length is a 2 bit, and payload is ranges from 46 to 1500 bits, and the frame check sequence is a 4 bits. This is defined depending on the total bit code. It will be stable bit code. SFD will be stable bit code 1, and destination and the source address bits are stable, and Ethernet type or length also stable, and FCS also will be stable. But payload is not be stable, isn't going to be stable. It ranges from the 46 to 1500. If we have a 50 bits in a payload, you will add up 50, and this all remaining 7 1 16 16 and 2 and 4, and you will calculate all this and says this is our uh, total Ethernet frame range. And then next we see tagged Ethernet. Tagged Ethernet we use when we are configuring the VLANs. Let's see tagged Ethernet. In tagged Ethernet we have extra tag here. The tag bits adds in between a source MAC address and length or type of the Ethernet frame, and the tag bit contains four of the byte chunks. There are type, priority, tokening encapsulation, and VLAN ID here we see, and it's a 4 byte tag. The 4 byte means each byte is 8 bits, and totally it will be 32 bytes. And let's calculate what's into this tag and how it works. Why we use this? The tag we use for specifying this Ethernet frame is for specific VLANs and carry this Ethernet frame to specific VLAN. Without this tag bit, it only the original Ethernet frame only will transfer or route this traffic to only one Ethernet frame. That will be access port, and for the trunk port we use a tagged Ethernet frame. So let's see what this 4 byte tag field is. And the first one is tag protocol identifier. This is a type, what type of the tag it is, and it's a 16 bit. It's always like 0x 8100 in a hexa mode. Let me write it in a notepad. Tag bit contains type, priority, token ring encapsulation, and VLAN ID. And let's learn what are all these. First, the type, what type of what type of tag bit it is. The first tag bit it is always it is 0x8100 hexadecimal format. And why the type is used for is it tells the device this frame is VLAN tag, and when it reach to the specific gateway it will say this this frame, this data frame, this is a tag, this is a tag. Let's see it's a original one, and let's say it's also added, and this tag says this ethernet frame is routed to this VLAN ID, whether it's 10 or 20. If we specify 20, this will ethernet frame will transfer to VLAN 20. We have VLAN created two VLANs for the PC1 and PC2. So if we specify 20, this ethernet frame will transfer to VLAN 20, that's a PC2, and if we specify it 10, it will transfer to VLAN 10, that's a PC1. So let's see, for now let's make it a ID, and let's say the priority, the priority also called priority code point, it's a 3-bit code point and used for checking the quality of service. So the values ranges from the 0 to 7, and if if the priority is higher, let's say it is 0 to 7, and if the priority is higher, then it have a higher priority. I mean, if the value is higher, the priority will be higher. Let's say type is always 0, always 0x8100 in hexadecimal format. Hexadecimal format. Yeah. In priority, if you have a higher priority, higher value, it will give you higher priority. If this Ethernet frame having priority 5, this will have a more than minimum of the priority. If it have a 0, it have a least priority. If it have a 7, it's a higher priority. And about the token ring encapsulation, it's before we say CFI or canonical format indicator. Before previous, sorry, let's do this here. Token ring encapsulation, previously it calls CFI. CFI stands for canonical format indicator. Format indicator, and it is used in token ring bridging. Used in token ring bridging. Now it's changed to now it's changed to drop eligible. If you set this drop eligible, the frame can be dropped in congestion. Congestion doesn't mean when you have a collision in a network, like when you have a traffic jam on the road, and this frame is dropped in there. And the next one is VLAN ID. VLAN ID. VLAN ID is 12-bit. VLAN is 12-bit, and it ranges from it ranges from 124094 bits. And if it ranges from 0 to 4095, it is a reserved. It's a reserved range. So it is identify what do VLAN ID do when you have a VLAN ID 10, 20, VLAN ID 30. Like, it identifies specific VLAN. Let's go back to our configuration, and let's configure again. Enable conti, and let's configure again interface G0/0.10 and encapsulation dot 1q, and specify VLAN ID 10. And here we see, and let's assign IP address 192.168.10.1 255.255.255.0. And no shut. Don't, why we use no shut? Don't be shutting up our connection right here. Power up. And let's say interface G0/0.20, and it changes to another interface, another subinterface dot 20. And let's say encapsulation dot 1q, and let's specify VLAN ID 20 and assign IP address 192.168.20.1. Why we use a different IP address? Because we have a different VLAN, so we need to use different IP address for the different VLAN interfaces. So let's subnet 255.255.255.0 and no short. And let's give IP address for the PC. IP configuration 192.168.10.1. Sorry, that's a gateway. 192.168.10.2. Let's copy and paste in gateway and change it to 1. Don't forget to change it once after copying, if you don't manually type it. And let's see that carefully. If you have a different IP address, then default gateway here. And let's go back, try to run the ping command, ping paste 10.2, and here you see we are getting reply from the gateway. And let's also do IP configuration for the PC2 in a VLAN 20. And sorry, let's go back here, IP configuration, and let me paste it, change it to 20 here, change it to 1 and 20. And let's run a ping command for the gateway and also PC1. First to gateway 20.1. We are getting the traffic from the gateway. Let's see for the ping for the, we are getting from the VLAN 10 gateway. And let's try for the PC2. The request timed out, but again first packet has dropped. When we sent 4 packets, received 3 packets. one packet drop because the ARP, ARP table doesn't have the PC2 address at the beginning. So when we send a echo request, it takes one packet drop, and it will say here you take my IP address and MAC address and get back to PC2, and the ARP reply will be taken back. That will be reverse ARP, and then you will be building the ARP table. When you send a second packet, it will directly look into the ARP table, and it reaches to the PC1. And let's go to switch and check VLAN configuration. Enable sh VLAN. Here you see we have HR and sales, and let's go to router and check the IP configuration here. Exit and exit sh IP in brief, and here we have two IP address configured for gigabit Ethernet 0/0.10 and 0/0.20, and here you see three interfaces of 0/0, 0/0.10, 0/0.20. And you can ask why this IP address is unassigned, because this is a parent and we didn't connect any devices to parent gigabit Ethernet. We directly connected with VLANs in a interface G0/0, and still we need to opt this gigabit Ethernet because this is a parent, this is the gateway traffic, and share and do this routing between a WAN or outside of the network. So we have configured successfully, and let's also check from the PC uh, PC communication from the router 192.168.10. First gateway, and we have a traffic to the gateway and C to PC, and yeah, PC1 also responding. And let's check for the PC2 gateway, and yes, still we getting the PC2 gateway communication, and PC for the PC also we are. And for the better understanding, I would say when you are done all the configuration, select all these commands from the starting. For we're starting from here, and copy this command. Don't use any keyboard clicks, it doesn't work. You just need to use this interface one and a copy, and you should paste it in a notepad. I have created this I have created this tab like this. I have put first lab title and a subtitle for the router configuration commands, and I will paste it here, and to check later if after configuration, if the ping doesn't work, you can get back here and check what are all the commands I have given, and if there is any command misspell commands or mistaken errors, and you can check it here and reconfigure this. And also after you paste the router one, let's do subtitle switch, sorry, and let's paste switch configurations also. And let's copy only the commands that we have done before here. and these are the commands I have configured in a switch. And right now you have all these, and if you don't want all of these extra messages, you directly go to router or switch, and if you type show sh history, and it will show what are the commands you have used until now, and you can copy it directly and paste it there. Let's try to work it in a configuration mode also. Sh do sh history, and here you see these are the commands we have used in global configuration mode to configure the IP address. Just copy these commands and paste it in a notepad, and at the end check what are all the commands you have configured. If you face any error, and you can recheck these commands, and if you see any error there, and you can reconfigure them. So this is the video for today, and I'm closing the video for now. Thank you for watching my video, and I hope you enjoy and learn something from this video. I will post a tomorrow video related to the static routing. We will learn a static routing in the next video. If there is any resources I have to put in, I will post it in description, and you can access the packet tracer file, and also the resources that I'm going to give you the images of the ethernet and all. Any information if I have to, I will update that. And hope you enjoying my videos. Hope you like and give me some support. Thank you.